This is the solution of the previous activity where you need to send a counter from the Arduino to the Raspberry Pi, and then every 10 seconds, so independently from that first action, you're gonna reset that counter from the Raspberry Pi to the Arduino. And let's get started, and as always, I'm gonna start with the Arduino code. So let's create a int counter is equal to 0 here as a global variable, and then I'm gonna initialize, so I'm gonna set up the serial, so serial dot begin with the baud rate, and while serial like this. Okay, serial is ready. I am going to create two new variables here, unsigned long last time, let's say counter sent is equal to millis or 0, and then unsigned long counter, so actually send counter delay is equal to 500 milliseconds. In the void loop, unsigned long time now is equal to millis, which is the current time. If the time now minus the last time we have sent the counter, so this is a duration, is greater or equal than the delay, what we do is, so we enter the if, and we say that the last time we have sent the counter is equal to time now. So I go pretty fast with that because, well, that's a command structure we have already used before. And then what I do is I simply do serial.println with the counter. So it's gonna send 0 the first time, and then I do counter plus plus. So basically, this is gonna send 0 and then 1, 2, 3, 4, 5 every 500 milliseconds. Okay, and the counter is gonna increase indefinitely. Now let's add the second action, which is when we receive the reset counter command, we reset the counter. And here we need to choose exactly the string which will correspond to that command. And actually, let's just use that string, reset underscore counter. Okay. So what I usually do when I send data over serial like that with comments is I put underscore, okay, if I need to separate two words. So here we have the first action, which is going very fast and is non-blocking. And then we do if serial.available strictly greater than 0. And then we do string command is equal to serial.read string until \n with single quotes and semicolon. And then if command is equal to reset counter. So this command should be exactly equal to reset counter. Okay, so if you send, for example, counter reset or any other string, it's not gonna work. So open close curly brackets, and then what we do is simply do counter is equal to 0, and that's it. And then we have the else, but in the else we do nothing here. So any command that you send that is not reset counter is just gonna go nowhere. Okay, we are not gonna process that. We're just gonna process the reset counter. So that's it for the Arduino code. What we can do is we can already try this. So let's run this on the Arduino activity 3. Compiling, uploading. Okay, done uploading. I'm gonna open the serial monitor. We receive 0. Okay, you can see here we have restarted the program actually, and we have 0, 1, 2, 3, etc. Great. Now if I send anything, nothing happens. If I send a reset counter, boom, the counter is being reset to 0. So it's working. Now let's go to the Python program, and I'm gonna go back to the previous activity and just copy this for the structure, okay? And let's remove everything in the while true. Okay, so once again, I use the same structure here, so I'm not gonna write it every time. And in the while loop, what do we do? So the first thing we need to do is to print the counter that we receive. Okay, so if ser.in waiting is strictly greater than 0, once again, don't forget there is no parenthesis here. So if we have received something, we do, so counter is equal to ser.readLine.decode with utf8.rstrip, and let's cast that to integer also because counter is an integer. And we simply do print, let's say received counter plus, and we print the counter and we cast it back to string, of course, because now that's an integer. All right, let's already try this code. So the code here is running on the Arduino. Let's try this code. I run the script. Let's name it activity 3. Okay, it's gonna open this. Serial, okay, received counter 2, 3, 4, etc. So as you can see, I'm gonna kill it. I'm gonna start again. So we have serial, okay, and we start to receive the counter at 2 here. Why is that? Because, well, you have the time.sleep to give the time for the Arduino to actually start and set up the serial correctly. And then the Arduino is gonna directly start to send data, okay? So it's gonna start to send 0 and then 1, 2, etc. But basically, the time that you sleep, the Arduino already has sent 0 and 1. And at that time, after the time.sleep, you do serial.reset input buffer. So the 0 and 1 here are not processed because basically they are sent before you reach that line, okay? So actually, let's run this and comment the reset input buffer. I'm gonna run that again. And you can see now we receive 0 and 1, but if you check very carefully, we receive that directly at once, okay? The 0 and 1 is gonna go in the buffer, and this is gonna be triggered for 0, 1, and 2 directly without any delay, because 0 and 1 are actually already inside the buffer. So what's gonna happen is that if you don't reset the input buffer, any data, any command, anything that's gonna be received basically during this time.sleep is gonna be processed at once, everything basically at the same time. So that's why I basically also add a reset input buffer, is that you don't process many commands at the same time at the beginning, and you start from this point, you start with a clear input buffer, and then you only process any command that you receive after that. Okay, so we're gonna continue like this. Okay, you can see received counter 2, 3, etc. And now, well, the second part is that, so we received the counter correctly. Now, what we're going to do is we are going to reset that counter every 10 seconds. And to do that, we are not going to use time.sleep, because if we use time.sleep, well, what's gonna happen is that this program is gonna be stuck for 10 seconds. Okay, we are not going to go with this line. And so when we go to this line after 10 seconds, this is gonna process everything in the buffer. So we're gonna see received counter, for example, 2 until 11 at once, and not just when we receive it. Okay, we're gonna see that late and all at once, because they are gonna be stuck in the input buffer. So what we do is, I'm gonna do here, I'm gonna add a variable last time reset counter is equal to time. Okay, if you do that, you get the current time with Python, and then reset counter delay is equal to 10 seconds. So here we use seconds, okay? And then here you have while loop. So while true, if you have this, you enter this block of code. This is gonna be very fast. And what I'm gonna do is I'm gonna add another action. So here that will be action 2, and here action 1. So we get the current time. So time now is equal to time.time. So as you can see, the structure is very similar to what we do in C++ with Arduino, all right? If time now minus the last time we reset the counter, if this is greater or equal than the delay, we enter this if, we do last time reset counter is equal to time now. Okay, so exact same structure. And what is the action? The action is to send, so ser.write reset counter, so the exact same string here, \n dot encode with UTF-8. All right, and that should be it. Let's actually do print send reset counter command. So we know exactly when it has been sent from the Raspberry Pi. And let's try this program. Okay, let's see if it works. Run script. Okay, received counter. So basically we're gonna wait 10 seconds. So we should be around, okay, you can see send reset counter command and then we receive 0. Okay, let's continue. And you can see around 20, so just before 20, we reset counter command. So we can actually see that it's correctly working, okay, because here we send the counter every 500 milliseconds. So 10 seconds means that we have sent 20 times the counter, which is what we have done here from 0 to 19. And then we send the reset command from the Raspberry Pi to the Arduino. On the Arduino, we reset the counter to 0 and we still continue to send the counter and receive on the Raspberry Pi. All right, and that's the end of this activity and also the end of this section. Let's now continue by adding more functionalities to the Arduino and use them in collaboration with the Raspberry Pi.